2022 A-Level Physics MCQ question number 31. A current carrying metallic wire with different cross sections is shown in the figure. Consider the following statements. Statement A. The current in the wire is same everywhere. Statement B. The power dissipation of the wire is higher in the thin section than that in thick section. Number C, statement C, the drift velocity of electrons is higher in the thin section than that in thick section. Of above statements, only A is true, second only B is true, third only A and C are true, fourth only B and C are true, fifth all A, B and C are true. Consider statement A. Statement A. The current in the wire is same everywhere. Current, the value of the current gives this statement Q equals IT. You know, in current electricity, Q equals IT, I equals Q over T. That means current means Q over T. The charge moves per second in every cross section. In any cross section, current means charge particles through per second in any cross section. In this statement, the problem is, what is the meaning of everywhere? What is the meaning of everywhere? That is the problem. Actually, this means any cross section. Don't take in any point. That means any cross section. Everywhere mean. In every cross section, current should be equal, because if the charges inserted in this place, the quantity moves per second should be equal, because charge particles can't store in any place. Therefore, every charge particles inserted in this place should be go through any cross section per second and out for per second. Therefore, current should be equal in everywhere mean any cross section. A is true. Statement B. The power dissipation of the wire is higher in the thin section. Higher in the thin section. Power dissipation. Power dissipation is equal VI or V squared over R. No, I squared R. I consider power is equal I squared R. In the thin section, R is higher. R value is higher because we can consider this one. R equals rho L over A. Thin means the cross section is smaller, therefore R is higher. The total value R goes higher when the thin section. R is equal rho L over A. When A is smaller, thin section, therefore R is higher, therefore power is increased. Therefore power is increased. When A is decreases because of thin, R is increased, therefore power also increased. Therefore, statement B also correct. Therefore, statement B also correct. Now, we can consider statement C. Statement C. The drift velocity of electrons is higher in the thin section than that in thick section. In the thin section, the drift velocity is higher according to statement C. Consider this I equals AVNE. I equals AVNE. I is current, A is cross section of the wire, V is drift velocity, N is charge carrier, number of charge carrier per cubic meter or per unit volume. Number of charge carrier, N is number of charge carrier in unit volume, E is the charge in a charge carrier. E is the charge in a charge carrier. That means when we consider the current, the charge of a charge carrier is equal charge of an electron. E is the charge of an electron. Then V equals I over ANE. If we consider thin section, A is decreased. Therefore, this total entire term goes higher. Therefore, V is higher at thin section. The drift velocity is higher at thin section. At thin section, the drift velocity is higher. Therefore, C also correct. The answer is fifth one.